Hello everyone, this is another tutorial, ABAQUS tutorial. So in this tutorial, I want to consider the structure soil interaction behavior. So we have a structure and we will embed this structure in the soil, and we want to see how this responds during an earthquake. Here is a typical structure plan, and this is a 4 meters bay, 2 bay, and it's irregular shape, and 7 story, 1 story, 2, 3, 4 story, and each story has 3 meter. And the soil is 30 meter by 30 meter. So here I use millimeter, and the depth is 10 meter. The material we're using is here is one paper. I want to use this material for case 1, and using elastic modulus is 60 megapascal, and the position ratio, fraction angle, and the dilation angle, and this is the cohesive plastic stress, and also absolutely plastic strain, and this is also the density. So we want to go to the ABAQUS. Here is in ABAQUS. I'm going to create a model called soil. We want to consider that soil is a solid homogeneous structure. The unit is meter, so I can take it 30 and 50,000 first, minus 50,000 in the x, and 50 minus 50 in the y. So 1 point, and the second point is positive 15, and we created a structure, and it's asking me to give the depth. So the depth is 10,000 or 10 meter. Now we created the soil part, and the second is I want to consider a mat foundation. The mat foundation is equal to the length of this structure and plus 1 meter edges, so 10 by 10 meter, and the depth is equal 1 meter. So I'm going to here, and I can call concrete foundation, and the same material we used, and again I want to give minus 5 and minus 5,000, and again positive 5,000. We create it, and the depth is giving 1,000. Now we created the mat foundation as well. The next is the beam column section. So here I'm going to give the beam. Beam section is I use box, which is 300 by 200 by 20. So the height is 300, and the width is 200, and the thickness is 20 millimeter for the entire structure. For the columns is also box, is using 300 by 300 by 25. So now we have these two sections. For simplicity, we consider box and also same section. We're going to create two sections, one column. The column should be a wire, planar, and I'm just going to here. So the length is equal to the height of the structure, which is 3 meter, 3,000. And one more, I can go to here and just copy this one copy, and this called beam. In the beam I want to edit, just change the length to 4000. Now it's done. Like, okay. We define the material. We have 3 material, one for concrete. For the concrete I want to use CDP material. For the steel material I want to use Q345, which is the yield strength is 3500 megapascal. So I want to check my library. Here is some material. This is for steel, and this is concrete CDP 25 for concrete. Now I want to define a material called soil. In the soil, here is density. We're going to back to this paper, and here's giving the density is this one. So this is kilogram per cube meter. So I'm going to change it to 1.19 E minus 9, which is changing to 2 per cube millimeter. And the second is elasticity. In the elasticity, elastic is 60 megapascal and contribution is 0.5. This is 60. Here is we use megapascal exactly because Newton per square millimeter is megapascal, so 0.45. And from the plastic we use more Coulomb plasticity, and we have fraction angle. So fraction angle 0, dilation angle 0, based on this. And this is the in the cohesive behavior here, and cohesive yield is 150 kilopascal. So if I want to change kilopascal to megapascal, so then I can give it 150. Now it be 0.5 because it's 1 power 3 and that's 1 power 6. So now we're going to this, and so absolute strength in this is 0. Now okay, so we finish that one and nothing is left. And now we go to create some section. So first section is I want to create a profile called column. The column is box, and this is the weight A 400 by 300 by 300, and you can change if you want to change the techniques in this side. So basically uniform means 25 millimeter. Now we finished one, and again I'm going to call the beam. The beam is the A, which is this one is 200 and 200, and the height is 300, and the thickness is 20 millimeter. So now we finished. We're going to create called beam using beam element here and selecting beam. The material is steel 345. So let me show you that steel 45 has these properties, and this is the density, and this is the elastic, and this is the plastic. The concrete is CDP. This is the density, elastic, concrete damage parameters, and compressive strength is maximum 65 megapascal. Tensile behavior is this one. And now called list called column, same column, same material, concrete concrete solid element and using concrete, and the distance called soil homogeneous and using soil. Now we're gonna go to assign, and this is it. This is beam, column, and concrete foundation, and this one is soil. Now material is added, and we go to the assembly. But before go to the assembly, I want to create extrusion in this section. So I go to back AutoCAD here, and this is 10 meter in the center of this 10 meter. So when I take 10 meter, it's 30. So 10 meter this side, 10 meter this side. So I'm going to draw in the center a 10 meter rectangle. So go to here, and in the path, use this function cut, selecting this surface, and here. Now I can draw a rectangle, and like this. I wanna take this side measure. This one is 10 meter, and one to this side is also should be 10,000. So it's too much. 10,000. Now again to this side also should be 10,000, and one also from this side should be 10,000. So now I created the foundation, and the only thing is I want to extrude this. You can select here curve line and give 1 meter depth. And now here is we go to the assembly and bring soil, and this is the soil. I want to rotate this. Okay, I want to bring the foundation as well. Want to take the foundation and putting this one to here. So exactly it is the same. I'm going to rotate this one by these angles. Again, I want to select all and taking that point to 0, 0. Now here is, if I go to part, and it's two parts. One is soil, one is concrete. Now what's next? I wanna select this, and I'm gonna go to called remove selected, and just this one is left. So I should create some we call the base plate to connect that steel to the concrete. So I should go to the back to part, and this time taking the concrete foundation. Here I want to and now I want to make some partition. I use here is called data plot. Create some data plot, selecting this one and entering value. Flip this side is 1 meter here, and this area, and 1 meter, and this side as 1 meter, and here, okay, and 1 meter. Now I can select data plane, selecting this data plane here, and this one, So we created this that can visualize the location of 4 columns, and I want to make one more in the middle and one this side. Now I can go to create this one and selecting this. So the first flip, it is 5 meter, 1 meter this side and 4 meter this side, 5 meters. See here, and we select this one as well, 5 meter. Now we created 2 other. We'll select and selecting this one. Now we can create the other side as well. Now we have one column, 2 columns, 3, 4, 5, 6, 6 columns location. Now it's done, and what I want to do is to bring the columns. I'm going to bring the column, and here is the column. I'm going to rotate this column, this using this direction, and it should be up. And next I want to take this column and this node to putting here. And next I want to populate this one, selecting this direction, and it's giving 5,000, 4,000 here, and there is also 4,000 in this direction. So one more here. Okay, and just selecting these 2 and selecting this direction and giving 4,000. It should be front. Now it's okay. Well, the first floor column is completed, and we're going to bring the beam here. Go to beam. It's it. So I'm going to move this beam, select this beam, putting to this point, and it's it. And I can go to populate this beam as well using this direction. And here is the next. Okay, and I want to bring one more beam, and this time I want to rotate using Y angle. So selecting that one, this one. Now I can select this one and point it to this location. I can turn off this one and just keep that. Now I want to give this one 4,000. Here is 4,000, and giving this one also 4,000. Selecting this direction. Yeah, and I'm going to come back to here, and here is now okay, and just 2 more. And this is 4,000 is okay, and just selecting this one and giving 4,000, and this is 0. Now the one story is completed. I can select all and then populate two apps there here, and this one is 0. I can go to give 7 story, 1 2 3 4 5 6 7. So now this is the structure is completed. Structure is completed. So what we're gonna do is I want to use merge. Now it's called steel frame using butane. And now it's finished, and I can bring everything here. So next I want to go back to the part to define some orientation for the steel frame. So that means the structure is a moment resisting frame. And now I want to go to the one of the geometry and selecting the orientation, sorry, in the properties, and going to orientation and selecting these beams, and I can go here, those beams. So we'll fix first. Let's give this one how it looks. Okay, then I'm going to view part display option B, and now it is correct. And next is ZY, and selecting this and this, and I'm giving to, again it doesn't work, I'm going to 0 0 1. Okay, I'm going to give 1, and this is okay, and let's see how it looks like. So the beam is correctly assigned, and the last one is we go to the give the names. So column is actually same. I can go to give okay. Now we can see it's a moment resisting structure. Now we can go to the assembly, and even we can view the rendering here as well. And this is it. And now we can go to the step. So I want to first consider do a model analysis to see the frequency of the time period of the structure. So I'm going to call frequency, and here select frequency analysis. So here ask me to number of eigenmode you want. I want 20 modes. So we don't need anything. We go to the interaction. In interaction, we have we want to create a tie connection between this and the concrete, and contact between concrete foundation and soil. So I'm going to here to find out that connection. Here is four area, so that area and the bottom. So I can go to here, create a here a properties contact. The contact is tangential behavior and some fraction between concrete, and here is 30, 35, and also normal behavior out contact. Now I can select this is the interaction properties between these two. So we created this, you can see, between concrete and soil. So the next is between rebar, between frames and concrete. So we need to consider the anchors and also the base plate. So what I want to do is I want to go to define some reference point. I go to back to select, go to here, part, I'm going to concrete foundation. So just I want to this. Here is tool, we want to create some reference point. 1, 2, 3, 4, 5, 6, 7, 10. So this is it, 8 number reference point. And also I want to go to the mesh, and in mesh I want to first give mesh this part, concrete frame. I want to mesh this, so I want to use a mesh 400. Let's see, 400 is okay, it's not bad. This is it. So I can go to back to assembly, and I want to shoot this one. So here I want to create some node set. Some node set. So let's suppose this is column 1, column 2, column 3, 4, 5, 6, 7, 8. I'm going to call set manager and create called C1. I select node, and in the node I select this one. I want to go to the let me ZX, and using this one. Okay, and just I want to create ZX. So if I go back, so ZX is that entire select, and C2 node. Now go to C3, C4, and C5. C6, C7, C8. And now we created some sets, and now I want to go to interaction. So first of all, I want to consider a base plate with anchor is created in this region. Then the end of that point is the reference point. So I want to then connect that reference point to the end of the beam columns. So I can go to interaction, and I want to see that's a tie connection. So there is no movement. So exactly that tie. So I can call C1 again, and I select and node region. So node region is first I'm going to select that point, and again calls node region. So node region is going to use C1. Now I created one single point, and if I go to here is that point to end of the foundation. Now the second is also C2, and selecting node region, selecting this point, and selecting node region, selecting C2. And now let's console create tie C2, and node region, selecting this one, and node region, selecting set C2. Now you can see we did a mistake too. So this is I should go to back again, XZ. So we came here because this was 1 2 3, this was 1 2 3, so this is 1 2 3, so I made a mistake, and I can fix that one. Go to OK, and here the big point, let me first check. The first one is okay, so second one is should be this one, third one is this one. So I'm going back to create another C2, and okay, so node region is selecting this one, and node region selecting C2. Now it's okay. Now we're gonna go to continue like this. C3, node region, selecting this point, and node region set. You can see now it's okay. Now we're gonna go to okay. 1 2 3 4 5 6. Let's C4, and node region. I'm not sure which one was C4. Let me check this one. Go to node region, C4, yes. C5, node region. I'm going to select this point, and node region, and select again 5. Okay, and C6, node region, and selecting this point, and the node region, selecting this one exactly, and C7, and this is C7, node region, and node region, and selecting node, set. Okay, and the last one, C8. Now it's finished. So what we're gonna do is we have one contact here, and then we want to take that point to the exactly to the structure. So now I can bring the still frame. This is still frame. I'm gonna add it, and I can go to view and now display and time of the rendering, and I go OK. So now we have uh, this one, and I'm going to create called uh, I can call C to F, concrete to foundation geometry, and I'm going to select this point. Sorry. Create a tie connection, not set. Here is set in tie connection called column to front. Now a smooth region and selecting this point and smooth region, selecting the end of this beam. So I should do one thing. Let me it will go back, and I want to concrete foundation should remove like this, and selecting so I can do one things and just go to back to here and give the still frame, make the still frame replaced, so others will go. So now selecting mutilation, and here now it's showing correct. And the second we go back again, this one using this condition, and copy. We can use no need copy, so we will called cf2, and select node region and selecting this one and pushing and taking this point node region. Okay, and we should continue like this. It's a little time consuming, and go back, take this node region, take this one, and then node region, I'm going to back to here and selecting this point. Now we created just a few is left. Okay, now we're gonna go again, cf cf1 1 2 3 and this is 4 node region, and I'm going to back to here to see. Hit cf5. cf7, and this is the last one, cf8 node region, and going to add this one, selecting this one, and node region, I'm going to back to this one, selecting this one. So now all this is fixed. And one more thing, in case if you want to change the slab node and master node, you can just go to edit here and repeat this one. So mostly the concrete should be slab and the peak point be master. So I'm back to here. Even sometimes is okay, no changes. Sometimes in case if you get it, we'll fix this. Now everything is finished. We fixed the structure, and we want to go to the load boundary condition, and go to create a boundary condition, go to the boundary condition, going to select this bottom and enter guess, and mesh, and we already meshed this one, and just going to still frame, and I want to mesh it so that 400 is okay. I'm going to okay, say okay, and I can, if I go to view to the power display, and you can see, yes, so it's meshed. And the last one is soil, and we can create some partition. Let's go to part, going to this one, and take this point and this point, and this is the last point, and this one. So we did some meshing, and you can go to the mesh now. It's green, and we can give 1 meter. It's okay. Now we created mesh, and we're gonna go to assembly and see the structure. It seems like this. In the view, I can go to display option. It is data point, and I want to show data point, turn off them, and also we can turn off this one. Now let's go to job and submit a job. Maybe there will be an error for the soil, because we cannot give the soil time period, so there is maybe an error. If we will see where we can motor submit. If we got error, then we will do another things. Just we will remove the soil and just concrete with frame. That's all. Sometimes it will occur, but sometimes it will not. So it's seems running. Yes, it's running. Here is no error. The model analysis completed, and we want to see the result. Now we can see the result, and in the first mode, so this is a very large information because we scale this, so this is very much, and you can take 1000, and now you can see it's here. And the first mode is not giving the structure time period because it's a very complex structure, so we should check another mode, and which mode is considering for the dynamic analysis. So this 7 mode 7, and mode 7 U3 is the largest one, and this direction we want to consider this one. And if I calculate this time period is 1 divided by this, it's almost become 0.34 second. And now I want to go to step and create the time history step, and here we have one I'm going to create called time history. Here is model dynamic. I'm going to use model dynamic for the time history. So this is the time period. I want to use this Kobe earthquake record. This is Kobe earthquake record, and I'm going to select this one, and I'm going to select this one, copy, and bringing here. So the step time is 0.1 second. 0.1 second, 0.01 second. Now the damping is we considering here the first mode 7 mode 7, and the end should be mode 7, and the time period is the critical damping is 5%. Okay, and we go to amplitude, create an amplitude, so called Kobe at quick. Now I paste this one, so we're giving 40 seconds, so other part is going to delete this, and this part should be deleted because no need here. Now okay, and we finished the step. So one more thing is I want to go to here, and let's say in case if you want to see the concrete failure, damage failure, and you can use integration point or every X unit of time. So let's suppose 1. And we want to create some output, some story output. And we can go to here and just total output, total input, total energy, and also some other parameter in case if you need this elastic energy, some strain energy, and this is strain energy. I want to get the output of this one. Okay, and now it's finished. So after the analysis completed, we can take some output from the top of the structure. Now we go to the loading. In the loading, we have this is boundary condition. And this is boundary condition, yes. We created in this second node. If I go back to here, step, not step, I want to delete this instead of, sorry, in here I'm going to delete this one. I want to delete this one, and create a new using any show, so that's better. So you just select this node, this bottom in caster, so it's fixed. Now we now we go to the here in the time history. We create in the second time history, and it's called earthquake. And here is called acceleration based motion. So we can select U3 and selecting the Kobe earthquake. This is acceleration factor, and this is G factor. So we need to change to millimeter because we use millimeter. So then we should times by 10,000, and this is it. So we create it. Now mesh is finished, load is finished, go to job, and we want to create a called time history. Time history analysis. Okay, and we want to submit it. And now the first step, which is the frequency analysis, is completed, and the second will start to perform the time history. Now it's almost completed, and yes, it takes some while to finish. And fortunately, it's finished. 40 seconds, which costs about 4,000 increment or step time. We can go to the result, and now here is the result, and we want to interpret some of the data. So this is the entire stress, one mesh stress, and you can just go to remove one part and see another one. So but just I want to create some output. List the first output. I want to see the top beam displacement. Go to here and go to unique nodal and node set. I have called top node set here, that point. I'm going to plot this one. Now here is the stress strain. Actually, we selected stress strain, and go back here. This is the stress strain of the top structure. Create again, and going to output here, not stress strain. Instead, I'm going to get the deformation. Going to here into the model and just pick a point. Let's take this point, plot it. Still I have something else. Okay. Unique model, pick a point, mixing steps. Oh, sorry. Node set, that top node. So it means the step is fixing, so I want to, this one should be turned off. Okay, now I go to back to here and plot this one, it's work. So when you have two step-based activities, so it doesn't work. Now here is the displacement, and we can see the maximum displacement is about minus 100. So now you can compare that minus 100 is it in the allowable drift or not. In case it's out of the allowable stress, so allowable drift, so that need to improve the structure. So next we also can go to see one more things, the contact between concrete and this is the concrete foundation, and I'm gonna remove it, and I want to now I want to see the stress in this between the concrete and the foundation. So how stress or force, which is will convert to the stress, how it will transfer to the soil. Going to here, and this time I want to turn off this one, and instead not miss stress, let me in Z direction, this direction, or the third direction in plan to third, and including just stress is okay without considering that. Selecting here, I should select integration point better. So select here, and then selecting one soil element in a plot, and it will create for us. And here is the principle, the stress in direction 3. So it's very less because mostly it is caused from the contact and from the movement of the two body, concrete and soil. So this is the end of the tutorial, and if you have any question, please put in the comment and I will find time to answer you. And see you next time.